Earlier on when I demonstrated Loik, I simply pointed it at the root of our sample vulnerable website, and Loik went away and made a heap of HTTP requests. Now certainly if you get enough instances of Loik making enough requests, then yes, it could take the service down. But a more effective way of launching a DDoS attack is to target specific features of a web application. So for example, anything that causes the password to be hashed. In the last module, I showed a graph of login timing, which showed just how slow it is to log on when a good password hashing algorithm exists. And that workload, hashing the password, puts enormous strain on the infrastructure if it's hit enough times. So if you were launching a DDoS attack, you'd be looking to target a feature of the app that causes high overhead, such as anything that hashes the password. So login hashes it, registration hashes it, changing the password hashes it. Any one of these three facilities that so many websites have would be a natural choice for a DDoS target. Another one would be a feature that connects to another service. So for example, a page that connects to SMTP. A password reset, for example, usually sends an email. If that's connecting direct through an SMTP server, there can be hundreds of milliseconds of latency on that. If you can launch a DDoS attack and have hundreds of different threads tied up trying to reset the password, that could well stop the application from serving legitimate requests. Another one again would be a resource that hits the database. And the reason for this is that often web applications will have a pool of available connections. And a connection pool DDoS would be where that pool is exhausted. So many requests come in from the DDoS attack that all the connections are used servicing those requests and are unable to service legitimate requests. So again, it's a similar principle. Keep the website busy dealing with the malicious traffic such that it can't serve the legitimate traffic. Also consider other high-load functions. So for example, perhaps running a report needs to execute an expensive database query. You may not even need that many simultaneous connections. If the database is working hard enough and an attacker is asking it to do it many times over in parallel, that could prevent legitimate queries from being run. Same again if there's a large dataset returned. So what if there's a search, for example, that returns a large number of results and it's hit over and over again, not consecutively but simultaneously? Is it going to be able to handle all those requests? And of course, from the attacker's perspective, that would give their attack much more leverage than if they just hit a very fast resource with very low overhead on the server. So these are just a few different ways that an attacker can accelerate the effectiveness of a DDoS attack. And it also should be a reminder for those defending systems to be really cautious about the resources that have a high overhead on them as well. So consider if they may pose a high risk to the threat of a DDoS attack.